Thank you for getting back. Our next session, visibility in the clouds. Introducing a new open source tool for cloud security. Please welcome our speakers, Ilia Rabinovich, Adversarial Tactics Team Leader, Sygnia, and Oleg Lerner, also Adversarial Tactics Expert in Sygnia.
Hello everyone. In this talk, we'll present a new open source tool that was developed in Sygnia, which allows you to identify new attack paths that can be leveraged by threat actors to compromise hybrid and cross-platform environments in the cloud. For those of you who don't know Sygnia, we are a cyber consulting and incident response company. Oleg and I are based in Tel Aviv, and before the COVID-19, traveled most of the time around the world and worked with companies to build the resilience to respond to attacks within the networks. Obviously, a lot of our efforts in the last couple of years was in supporting companies migrating to the cloud and investigate breaches within cloud environments. In the past 6 months, we developed capabilities which we leverage to significantly enhance our client security posture. And what we want to do today is to share one of those with you. My name is Ilia Rabinovich. I'm the Adversarial Tactics Team Leader in Sygnia. And together with me is Oleg Lerner, who led the research and development of the tool. And we also would like to mention Doron Vazgel that assisted us in the development process. We start with a few words about the threat landscape, what Cloud Scout is, and suggesting what are the next steps for our tool. So, while in the past we believe most of the attention was focused on the on-premise environments and the major cloud providers, during the last 2 years we are witnessing a shift to a new approach called hybrid cloud. You're probably familiar with the accelerated transition to cloud services and the adoption of cloud hybrid architectures. So this is a place where new trends and by extension, new attack techniques are emerging. So let's talk about some of the trends we're identifying. First of all, many companies utilize multiple cloud vendors and have many connections established between their applications and services. In addition, while in the past CI/CD pipelines were a separate technical procedure, now this area is brought into the cloud and allows building, testing, and deploying the code in one single place. Finally, new native cloud services and microservices replace other traditional IT and introduce new security challenges that can be exploited with relative ease. So, threat actors realize that adopting cloud trends and migrating the traditional infrastructure to another workspace is creating opportunities that they can leverage. Those opportunities pose significant challenges to security teams, both to prevent and detect their activities. As a result, there are 3 main areas that threat actors focus more and more on. So C2 workloads move to the cloud, and malicious cloud applications are spun up on cloud and hybrid infrastructure. In addition, threat actors leverage the expanding attack surface on the cloud to pivot into the internal networks or other cloud environments. And, threat actors focus their efforts on the creation of dedicated malware for cloud platforms. Look, there is a lot invested by security teams to adapt security of their cloud services to threats, and stay ahead of the curve in the competition with threat actors. What you see on the screen are just few examples on what it takes. We don't really have time to get into each of those, but using security infrastructure for administration and hardening of programmatic channels are just a few examples of the challenges that we have in this area. Moreover, to enable those, what is clear is that the key gap is to establish visibility into our increasingly complex cloud environments. Oleg will take it from here and present the tool and its capabilities.
Hello everyone, and thank you, Ilia. So we talk about the increasing use of cloud environments, solutions and trends which are extending the corporate boundaries. Corporate environments are now more and more intertwined with cloud infrastructure, and more organizations are transitioning to what we call a hybrid environment. While adapting hybrid environments, we are unintentionally adapting their new misconfiguration, gaps, and vulnerabilities, which in turn may expose our entire infrastructure to a security risks that could lead to full organizational compromise. Identifying gaps in these configurations manually is really hard work and very complicated. Thankfully, the community provides us with open source tools in order to make those challenges a bit easier. The tools you see here on the screen are widely used by security teams for enumeration and visualization of attack paths, leveraging gaps in different environments. On the left, we have StormSpotter, a tool developed by Microsoft and used for enumeration and identification of gaps in Azure. On the right, we have AWS Peaks developed by F-Secure Labs and used for AWS environments. And of course, we have a tool developed by SpectreOps called Bloodhound. I bet you're all familiar with, and it's used primarily for our on-prem domain environments. Currently, each one of these tools provides data collection and analysis for a single type of environment, represented by dots illustration below each one tool, either Azure, AWS, or on-prem domain. Each framework is executed separately under separate databases, and we don't have the ability to create relations between them, even though we know they do exist. In our assessments, we see many business processes that are cross-platforms and hosted on multiple cloud providers, interconnected to each other and, of course, to the on-prem infrastructure. In order to fully map or visualize the hybrid attack surface, we needed to manually consolidate the information collected by each one of the tools. I think we can all agree that it's not an optimal solution. So we would like to introduce Cloud Scout, a tool that significantly assists with you with the challenges we presented so far by providing 3 unique capabilities. Connect cross-platform entities such as users, applications, roles, and services based on their corresponding attributes. Identify cross-platform attack paths that allow attackers to move laterally and escalate privileges. And finally, visualize the cross-platform attack path on a single screen. Those 3 tools are all based on a Neo4j graph database. So we decided to expand those tools' functionality by merging them into one database, just as with real-life hybrid environments, where all organizational infrastructure is interconnected. After we collected all relevant information from our cloud and on-prem environment and uploaded into a single database, we need to find a way to create relations between different node types, which are actually linked one to another in the real world. But we cannot see or visualize them using each tool individually. For an example, we have users in our on-prem environment, which are linked to our Azure Active Directory. And therefore, we can create a link between a StormSpotter user to a Bloodhound user based on their security identifier. Beyond the trivial relations, the one we just mentioned, we enrich the data of different nodes and create a more complex relations that will show us complex and non-trivial attack paths which we couldn't see in the past. We will dive into more detail with the following demonstration. So here you can see Bloodhound application without our plugin installed. It's the default Bloodhound application you can download from GitHub. To install Cloud Scout, all you have to do is to download the plugin from our GitHub page and execute the batch installation script. After the installation will be completed, we will have Bloodhound with our Cloud Scout plugin installed. And as you will see, we'll have a few additional buttons to handle the ingestion of different frameworks and executing the logic to create relations between relevant nodes. What I want to do now is to show you how we can use Cloud Scout capabilities to visualize a non-trivial attack path we just talked about. After our relations will be in place, we will see the output of our queries, which we will explain in details right after the demo. The first attack path you will see on the screen demonstrates how an attacker can get access to an Azure resource called Key Vault. The second attack path we will see here is an attack path of on-premise domain takeover, leveraging user privileges in Azure that we couldn't see previously. Moving next to the next attack path, which will show us AWS full compromise, a path that starts from our on-prem user, which is able to abuse its Azure permissions to move laterally to AWS and take over the account. And as a bonus, we also created another capability that allows to map network security rules in our Azure environment to identify overly permissive access to sensitive VMs. This was a short demo of Cloud Scout, and now I would like to deep dive into the specifics of each use case. So the first use case we'll talk about is a use case of Azure Key Vault takeover. Key Vault resource can be very valuable for an attacker, as it stores secrets which can gain an attacker access to valuable assets. So on the right, we can see the targeted Key Vault instance. But our attack path actually starts on the left side with a domain joined workstation with session of a domain user. A domain user that syncs to our Azure Active Directory and is the same user as the on-prem. The user has contributor privileges over the subscription hosting the Key Vault, meaning that it has permissions to view content of the Key Vault, as it inherited down from the subscription level all the way down to the resource level. Now let's see the relations created at this path with Cloud Scout. We have a relation between our on-prem user to the Azure Active Directory user, which are the same identities as we just mentioned. The added functionality visualized an attack path to control Azure Key Vault that we otherwise wouldn't have seen. Moving to the next use case of a domain takeover leveraging Azure. On the right, we can see the domain admins group that we are targeting, as we know that domain admins will have full control over our domain. But once again, our attack path starts from the left, where we have a domain workstation instance with a session of a domain user. User, which is a member of a role in Azure called Groups Administrator, meaning that this user have the privileges to edit groups in Azure. In our path, the user will have the ability to edit groups which are member of another Azure role called Application Administrator. Gaining privileges of this role, an attacker will be able to assign credentials to an application service principal and act on behalf of it. The service principal we are targeting here has the contributor privileges over the subscription hosting the VM. Contributor role over a subscription inherited down to the VM. So the service principal has contributor role over the VM, which means that the attacker have the ability to execute code with system privileges on that VM. And we also can see that the VM instance is a domain joined. We can see that this server has an active domain admin session. With system privileges, an attacker will be able to extract the user credentials and compromise the whole domain. The relations created in this scenario by Cloud Scout will be between the on-prem user to Azure user, between an Azure role of group administrator to Azure groups, as he can edit those groups, between application administrator role to Azure service principal, as we have the ability to create credentials for those service principals, and between the VM instance hosted in Azure to the corresponding on-prem server. So Cloud Scout highlighted a path that begins in our on-prem environment and leveraging Azure in order to take over that same on-prem domain, again, by visualizing a relationship that we wouldn't have seen otherwise. Moving to our next use case, where we have a full AWS compromise. On the right, we will see the effective admin role, a role which grants a full control permissions over AWS account. And once again, the full path begins on the left side with our on-prem domain workstation with assignation of a domain user. A user with application administrator role in Azure. And as we explained earlier, those permissions grant an attacker privileges to act on behalf of the service principal. In our case, the service principal has the role rights to gain full compromise of the WAS environment, leveraging AWS configured access controls. Also, we can see here the relations created by Cloud Scout between our on-prem user to our Azure user, between the application administrator role and the service principal of Azure, and between the service principal to the corresponding role it has in AWS environment. In this instance, we have visualized an attack path through 3 different environments, relations that we wouldn't have seen without the functionality of Cloud Scout. Moving to our last case in this presentation, a use case that demonstrates a network map of allowed network rules from and to VMs hosted in Azure. We can see on the left IPs that have allowed inbound and outbound rules over Azure NSG, which are the network security groups in Azure. On the right, we see to which VM these network rules are attached. And we also can see the full path by which those rules are attached to the VM. So far, we are not familiar with any open source tool that provides this kind of functionality. So I hope you enjoyed the presentation so far. And before we wrap up, we wanted to share with you a few words about how Cloud Scout started. It started when we were assigned to assess clients' Azure cloud environment. During that project, we found that there are not many tools available for enumerating and identifying gaps in Azure. So we started developing our own tool. During the development, we've got an idea to integrate Azure collected information to the on-prem information we collected using Bloodhound, as we have attributes to connect them on. And hopefully it will help us to connect the attack path and show our more complex attack paths we were targeting. While we were busy developing our own tool, some tools for Azure were published and enriched our tool set. Yet those tools didn't automatically highlight the extremely complicated attack path we wanted to identify. Also, worth mentioning that Bloodhound version 3 was published. If we wanted to keep up the pace, we would have to update our code as well. Going further, we had an AWS environment to assess. We used AWS PX to identify attack paths in AWS environment, but we still weren't able to connect the dots between different environments. During our development and research, StormSpotter was published, a tool for enumeration and then for enumerating and identifying gaps and misconfigurations in Azure. We decided to embrace the comprehensive Azure enumeration provided by StormSpotter into our framework. And then we realized it will be extremely powerful to merge and extend the different tools using a single unified framework. At this point, we decided to create an external plugin for Bloodhound, which integrates all platforms under one hood, extends search patterns and capabilities, with the vision of supporting additional frameworks in the future. Now let's talk about a bit the plugin architecture. But before that, we need to be familiar with Bloodhound basic architecture. We can see that Bloodhound depends on SharpHound in order to collect the on-prem domain information. Bloodhound consists of 3 main parts. We have the visual part, the user interface we see and use, the database, the Neo4j database, which stores the information ingested. And of course, we have a logic behind the graph which creates the relation between different entities. Cloud Scout will have the same three general capabilities. We'll have the visual to edit functionality like buttons. We'll have the visual element, the icons we need to support from different frameworks, and text to be shown. In case of the database, we'll use the same database as Bloodhound. And we also need to support of ingesting other frameworks information. And of course, we have our own behind the graph logic to create complex relations. This brings us to the end of the presentation. But before we finally finish it, we want to share with you what we intend to do next. We are currently in the phase of developing support of processing private SSH keys to match with corresponding VMs deployed on our cloud environments. So we could map a bunch of instances that a private key has access to. Also, we want to create a tool for enumerating GCP environments. We will improve the integration with platforms and create new relations based on new researches. So we encourage you to try out Cloud Scout, which you can find on our GitHub page. Also, feel free to reach us and share ideas to improve our plugin and helping others to find potential misconfiguration and gaps in their environments before any attacker does. So we want to thank you for the time you spent with us, and we hope you found this presentation useful, and more importantly, that you will be able to leverage Cloud Scout for your security like we do. Thank you very much.